Hello guys, welcome to Simply Math. I'm Alan Ramos. Last week we talked about rational numbers. Now we're going to talk about irrational numbers. So irrational numbers cannot be expressed as fraction, and both are and this is non-terminating and non-repeating. Some samples are square root of 2 and pi. Square root of 2 is equal to approximately 1.41421 and so on and so forth. And square pi is just 3.141592. So I have some exercise for you. So let's see if you can answer this. So determine if this is an irrational number. So let's start with number 1. Number 1 is square root of 25. Since square root of 25 is just 5, we just and 5 is a rational number, therefore it's not irrational. How about How about number 2? 33 over 9. Is it a rational or irrational number? So since both are integers and can be expressed as a rational number, a fraction, therefore this is a rational number. How about square root of 11? Square root of 11 doesn't have a perfect square. So if we compute in our calculator square root of 11, that would be approximately 3.31662479 and so on and so forth. So it's a irrational number. How about 17 and 34? If we divide 17 and 34, since both of them are integers and they are expressed as fractions, we could say that this is a rational number. And how about the last number? 0.3033 0 333 0 3033 and so on and so forth. So since this is not a repeating and it has no pattern, the tree has no pattern, we could express this, and this is expressed as a rational number. So number 1 is a rational number. Number 2 is a rational number. Number 3 is an irrational number. Number 4 is a rational number. Number 5 is an irrational number. So moving on, real numbers are either rational or irrational, q or q prime, and can never be both, meaning that if it's a rational number, it could not be an irrational number, and if it's an irrational number, it could not be a rational number. And we can visualize this in a real straight line. For example, we could say that these integers, or 1, 2, 3, 4, 5, represents the numbers of the integers, and in between that, you could have 1/2 or square root of 2, and it has only one correspondence, or each number or each real number corresponds only to one point in the number line. We could express also real numbers as a subset. If you're taking a look at this subset, I have shown you this before, that natural numbers are 1, 2, 3, and the whole numbers, and natural numbers is a subset of whole numbers, which includes 0. And moving further, natural numbers and whole numbers is a subset of integers, which includes -3, 2, and 1, and all of the negative numbers. And in a bigger picture, rational numbers expressed as a fraction is the main set, or we could call that natural numbers, whole numbers, and integers are the subset of a rational number. But as we can see that the irrational numbers are not part of a subset here, but they are in a different set. So both of these, rational and irrational numbers, complete as a set of real numbers. Let's have some exercises and determine if we have a classification of rational or irrational numbers. So I have here some n, which denotes natural number, W, whole number, integer, rational, and um, rational numbers and irrational numbers. So we say that 36 or square root of 36 is 6. So since we simplified it as 6, and this is a perfect and this 36 is a perfect square, we can say that 6 is a natural number. Can we say that 6 is also a whole number? Yes. How about an integer? Since this is a positive 6, yes. And how about as a rational number? Since we could express 6 as 6 over 1, it is a rational number. How about 2.6 or 8 divided by 3? Natural number? No, because natural numbers are not expressed as fractions. Neither whole numbers and integers. But how about rational numbers? Yes, it is. But it could never be a irrational number. How about square root of 3? Since square root of 3 is not a perfect square, it could never be a natural, whole, integer, and rational number. Therefore, it's an irrational number. How about negative 5? There's no negatives in natural numbers and whole numbers, so we leave them blank. And it is expressed as integers. It could be expressed as an integer since it's a negative 5, and it could be expressed as a rational number because you can express negative 5 as negative 5 over 1, which is correct. How about 3.212212222? From our previous example, we have seen that the 2 is a repeating increases over time. So this means that it has no pattern, or it has no repeating values. So therefore, it's neither a natural number, a whole number, an integer. Neither it could be a rational number because it cannot express as a fraction. Therefore, it's a rational number. Irrational number. So guys, thank you for listening, and I hope that you've learned a lot in this video. Next week, we're going to talk about PEMDAS, which is the order of operations for real numbers.